What if the next revolution in computing does not come from quantum machines, but from raw scale?
Imagine a machine built around 1.2 trillion transistors. A scale of computation designed to push far beyond the hardware we know today. Not a fragile laboratory experiment. Not a machine waiting for extreme conditions.
While some experimental computers depend on extreme environments, another vision takes a very different path.
A computer designed to bring enormous processing power directly into the real world. The idea is simple: more computation, more control, and less dependence on distant infrastructure. But the real question is not how many transistors we can build. It is what happens when extreme computational power becomes an independent nervous system for the machines of tomorrow. If computing can reach this scale, what could the machines built on top of it become? To understand LHX, we have to look beyond the number of transistors. Because transistor density is only useful when all those tiny components can work together efficiently. The real challenge is turning enormous hardware scale into useful computational power. Every transistor creates new possibilities, but also new engineering problems. More computation means more energy, more heat, and more complexity to control. That is why the future of computing is also a race to rethink energy. If the architecture succeeds, its greatest value may come from what it enables AI to do. More computation could allow intelligent systems to simulate problems that are currently too complex to model. And that raises another possibility: computing where control stays much closer to the user. Because the next generation of computing may not be defined by the cloud, but by how much power we can place directly in our own hands. But computational power is only half of the LHX vision.
The other half is control, distance, who owns the information, and where that information actually lives. For years, computing has increasingly moved away from our devices and into distant data centers. That brought extraordinary convenience, but it also created a new dependency. Your data may travel through systems you never see, and infrastructure you do not control. LHX imagines a different model: powerful computing under direct physical control. That could change how robots, AI systems, and autonomous machines are built. Medical AI could process sensitive information without sending every decision into a distant cloud. Autonomous machines could make critical decisions locally, even when the network disappears. And that may be the ultimate test of independence. What happens when the outside network goes silent, but your machines keep thinking?
Now imagine the network disappears, but the machines do not stop.
A hospital could continue operating even when the outside world is disconnected.
A vehicle would not need to wait for a distant server to tell it what to do. Factories and farms could continue making decisions without depending on a permanent connection to the cloud. This is where local intelligence becomes more than convenience. In a disaster, independence could become the difference between waiting for help and creating it. The same architecture could bring advanced intelligence to places where connectivity is impossible. And on Mars, local computing would not simply be useful,
it could be essential. When Earth is minutes away by radio, waiting for instructions is no longer an option. The farther humanity travels from Earth, the more valuable independent intelligence could become.
But the most important question begins when you put advanced AI on top of extreme computing power. Because intelligence is ultimately limited by the systems available to run it.
Give an AI more computational resources, and you can potentially give it more room to reason.
Instead of thinking through one problem at a time, machines could explore enormous numbers of possibilities in parallel.
Climate models, medicine, physics, and engineering could all benefit from that scale of computation. A machine could test possibilities in hours that once took researchers years.
New materials could be discovered by simulation before humans ever manufacture them.
Entire cities could be designed by testing millions of possible futures before construction begins. And this raises a question that becomes harder to ignore. How intelligent could an AI become if computation stops being the bottleneck? Because once computing becomes abundant enough, the next limit may no longer be the machine. It may be the intelligence itself.
If computing becomes abundant, artificial intelligence could become far more accessible.
AI would no longer have to live somewhere in the cloud. It could live directly inside the environments around us. Personal AI could become less like an app and more like an intelligent companion that understands your world. Education could become deeply personalized, with intelligent systems adapting to every student in real time.
And then something even more powerful could happen. AI could begin designing better machines for itself.
Better algorithms could design better hardware, which could then run even better algorithms. For the first time, software and hardware could begin improving each other at machine speed. And that is where the story becomes much more complicated.
Because intelligence we cannot fully understand becomes difficult to control.
The real question is no longer how powerful our computers can become, but whether humanity can remain wise enough to control what that power creates.
There is a point where more intelligence creates a new problem, understanding the intelligence itself.
An AI could reach conclusions that humans cannot easily explain.
It might find the right answer, without giving us an answer we can understand.
Imagine an AI managing an energy network too complex for any human team to control manually.
Factories could eventually coordinate themselves, from raw materials to finished machines. AI could even become a scientific partner, capable of discovering things humans have never imagined.
But the larger the system becomes, the more consequences a single decision could have.
At some point, humans may have to decide when to trust the machine and when to stop it.
The ultimate question of AI may not be intelligence, but control.
Because the moment machines become powerful enough to shape civilization, humanity must decide who is ultimately responsible for the future. If architectures like LHX succeed, computing could become infrastructure as fundamental as electricity. Buildings, transportation, healthcare, and industry could all depend on local intelligence. Computing could disappear into everyday life until we barely notice it is there. The most powerful computers may become invisible, hidden inside the systems that keep us alive. Science could move from observing the universe to simulating entire possibilities before they happen.
we could use extreme computing to understand Earth at a level humanity has never experienced.
And beyond Earth, independent computing could become the foundation of a new space economy.
Machines could travel where humans cannot, and make decisions without waiting for instructions from Earth. At that scale, computing stops being just a technology and becomes part of civilization itself. The machines of tomorrow may be limited less by what they can compute, and more by what humanity chooses to do with that power.
But technology does not decide the future by itself. The same computational power could create completely different worlds. One future could use intelligent machines to give people more freedom.
Another could make humanity increasingly dependent on systems it no longer understands. That is why the most important part of advanced computing may not be performance.
It may be responsibility. The systems we build must remain understandable, secure, and accountable. Because intelligence without accountability can become a dangerous kind of power.
The future does not have to be humans versus machines.
It could be humanity and machines, building something neither could achieve alone.
Perhaps the future of computing is not about replacing humans at all.
It could be about giving humanity tools powerful enough to solve problems we cannot solve alone.
Climate restoration, medicine, energy, and science could all benefit from unprecedented computational power.
And the more powerful our computers become, the more important abundant clean energy will become.
Computing, energy, robotics, and AI could form a technological feedback loop unlike anything in human history. The result could be a civilization where intelligence exists everywhere. But intelligence alone will never tell us what kind of future we should want. That decision will always belong to the civilization that builds the machines. So the future of computing may not be about how powerful the machine becomes.
It is about what humanity chooses to do with that power. The future of computing is not written yet. We are still writing it.